Okay, so I'm going to show you real quick how if you do this by hand, you're going to need the T table. And if you'll notice, the T table is a lot different than the Z table. There's not T values on here. So you would have to, or I mean, these are the T values. You'll have to look it up a little bit differently than you do the Z table. So first of all, there's 3 rows up here: level of confidence, one tail alpha, two tail alpha. This information right here that they're looking at, this one tail alpha and this two tail alpha, this is to be used later. Okay, so right now we're not using these two columns at all. And because of this, I am limited to if I was to use just this T table, I would be limited to the level of confidence that I could ask you about, because these are the only 5 levels of confidence that the T table will give you a value for. Now remember, what you use this table for is to find this value, the critical value. And where does the critical value come in? It comes in right here when you're finding the margin of error. Because remember, if you're not using StatCrunch to do this, all you start off with is this middle number right here, and we calculate the margin of error in order to calculate these. So we have to find that margin of error, and we do so using this formula right here. So here's the formula. So we use that formula. So we have to start by looking at the problem right here. It says 95% confidence interval. So we've got our C is 95.95. So that means we're going to have to go over here and use this column right here. Use this column, the 95 column. This will be where we find our number in this column right here. Okay. Now, the other thing that you need, obviously, is this right here, degrees of freedom. Now, this is where StatCrunch is a little bit more helpful, because it calculates the degrees of freedom without even telling you that it's what it's doing. You have to remember what degrees of freedom is. And I'm not even sure I've discussed it with my high school class. I know that one night my adult class and I discussed it, but I will run back over here and try to remind you what degrees of freedom are. So degrees of freedom, I believe I talked about if you have, I think the example that I use for the night class is if you had 7 pairs of shoes and you wanted to wear one pair of shoes, a different pair of shoes every day. The first day you go to your closet and you have 7 choices. So on day 1, you have 7 choices. After you wear that first pair of shoes, you don't have that one to choose from anymore. So on day 2, you have 6 choices. And you keep going all the way down. On day 3, you have 5 choices. Day 4, you have 4 choices. And then what happens on day, oh wait, I'm going backwards. 3, 4, 5, 6. What happens on day 7? You only had 3 choices, 2 choices. You might want to think that we're going to put 1 choice right here, but we don't. There's no choices. So think about this for a second. Okay, if you only have 1 pair of shoes left, that's not a choice. You have to wear that last pair of shoes. That's not considered a choice. You have nothing to choose from. Right here, you do have a choice. You have 2 pairs to choose from. But after you make this choice on day 6, on day 7, you have no more choices. So the number of choices that you have right here is 1 less than the number of number of days that you had. So your degree of freedom is always your sample size minus 1. And that comes to play right here in this calculation of the degrees of freedom, and the calculation of the samples. Dadgum, I can't find my word. S, what is that? That is the sample standard deviation. That is the sample standard deviation. That's what S is. And so in the calculation of S, they use those degrees of freedom. Okay. And so that's all we need to know right here. If N is 16, your degrees of freedom are 1 minus 16. So it's 15. So now when we go over here, we go down here to degrees of freedom. That's 15. So this right here is the critical value that we're going to use. So 2.131. So back over here, our degrees of, our critical value is 2 point, I don't remember what I said now. Man, my memory is terrible. 2.131. 2.131. Now, again, what was that used for? That would be used if we needed to calculate. Now, remember, we've already used StatCrunch, and we figured out what our margin of error is. So we're just going to calculate this a different way now. If we didn't have StatCrunch, here's how we would calculate it. We would take this 2.131 and we would multiply it times the value of S, which is our sample standard deviation, divided by the square root of our sample size. So 2.131 times 10 divided by 4. Square root of 16 is 4. So just do that on a regular calculator. I've got 10 divided by 4 is 2.5, and you multiply that times 2.131, and we get 5.3275. If you round that up, you get 5.33, which is exactly what we got a while ago. So that is just a second way, or without using technology, really, that's the way you'd find your margin of error. And then you would come back over here and say, okay, if I add 162 and 5.33, I get 167.33. And then if you take 162 minus, you do 162, you add the 5.33, and then you subtract the 5.33 to get your lower bound and your upper bound. And those would be these two numbers right here. This is your lower bound, and this is your upper bound. Okay, so that's how you do that with degrees of freedom and the t-table. Okay, I'm going to go ahead and stop it, and then the next video, I will show you how to use the calculator, and then I will come back and maybe work another example with you. But I'd like to leave you some of these to work on your own. Remember, I do have these worked out, I believe, on the teacher notes. Okay.